Hi, it's Warren Whitlock here, tackling the big topic of emerging technologies with you again. Uh, our goal here is to come up with practical application of the new technologies that are coming around, and sometimes just get into it, basically what it is. Go to first principles, explain primarily what something is doing. And today I got one like that: quantum computing. The quantum world is just phenomenal. It seems like I'm relearning everything as I study the everything about quantum mechanics in the quantum world. And quantum computing is the one that just is really going to make a big difference to what we're doing. And it's hard for us to see because for many years they've been working on this. And it's not the kind of thing where I can say, hey, look at my quantum computer. So let's talk first of all about what it is, and then maybe a couple of explanations. I'm going to tell you what we should be thinking about and what we might get out of it, the quantum computing. First of all, we all know computers get better and better all the time, no matter where we are in the cycle. Moore's law now going back 60 years, and some say even before that, in the way computing was done, if you go back to include counting, adding machines and early computers, and even an abacus, there's where you can say the amount of power it took to compute something. As the power requirements go down, the computational power goes up, and the big one that when Gordon Moore came up with this law was the price of the silicon and what you can do with it would go down. And so that's something that all projections say pretty much levels out somewhere about 2023, 2024. Read this decades ago. It's still there, but the law remains. That law is that about every 18 months, the amount of computational power doubles and the cost of putting it on silicon goes down. Right now, we've got chips that are at about 3 nanometers. And at 3 nanometers, compare this to 100 nanometers not that long ago. Most of your common equipment that you see now, your cell phone, your home computer, whatever, is at 5. And there's a lot of threes. The new cell phones have 3 nanometers. And what a nanometer is a very small measurement, but at that level, you start talking about only being one or only a couple atoms thick. And so when you try to pass signals over that, you're going to run out of atoms if it gets any thinner. So they're looking at other things happening. One of the big promises for the future to continue this Moore's law effect of getting more and more power is quantum computing. And it's because it fundamentally changes how we measure computing. So let's put it real simple. Quantum computing is to take a digital computer that has a 0 and 1, like a light switch on or off, and add to that the idea that it can be both on and off at the same time. And that adds up to a qubit, which is off, off, on, and on. There's 4 states just by one, uh, let's say light switch, because that's something we can all easily picture. When you think of being able to have 4 positions, not just on or off, but also more on and more off, or both at the same time, those kind of, however you describe that, to form a qubit. And then you start adding up more and more qubits, like computers went from a single bit processor to 2, 4, 8, 16, 32, 64. And the architectures of how the chips are put together are based on that number of bits. And each one exponentially grows how big you can grow the computer. And now with being able to fundamentally change that by more, it just seems going from 2 to 4, but you're really going from everything that we've accomplished and being able to start right at the beginning and multiply that out each time by that much. Right now, they're building quantum computers in very strict conditions of very low temperatures, very isolated, very clean, big rooms that are functioning only to have a little bit of quantum computing going on. and getting that down to just the quantum thing. They tend to make mistakes. We'll get back to that in a second. And growing them has been a little bit tougher. Now they're up to 50 or 100 of these qubits put together. What it does is it's able to do compute much faster, exponentially, and then it's like exponential times exponential fast. It's growing faster than anything we predicted with Moore's law, and it's able to grow a long ways from where they have it right now. The limitation right now is that temperature problem, keeping things cold, and then the whole quantum mechanics thing, which is, okay, I'm going to say it. I understand how to explain it, but it boggles my mind. And if you know about quantum mechanics, you're probably laughing at me already from the quantum computing explanation. But quantum mechanics means that when I turn my light switch, your light switch changes at the same time. There's an entanglement that's not wires that maybe is faster than the speed of light, although plenty of physics say it can't possibly be faster than the speed of light. And somehow those things are entangled. It doesn't matter if they're next to each other or if you have a speaker near another speaker in your stereo system, you crank it up, you'll see vibration in the second speaker. That's basically how a microphone works. And so one thing causes another thing. Ripples. If you drop a stone into a pond, you're going to see rippling effects of waves come out of it. And without getting into all the physics of what, but boy, I read a lot on this and really realize that I never have studied physics. But the entanglement means that there's a state to be able to find out something, and find out something, and as soon as you do, you've upset it. It's so fragile, or fragile by our definition, that if I try to look at what the results are, say I ask it to add 2 plus 2, and I look to see the result, it's going to change what 2 plus 2 did and cause more problems, that entanglement thing. Boy, I feel like I'm not doing it justice, but stick with me here. The point being that all of these things are being worked on, worked out, and every time I read about it, the experiment has gone a little bit farther. I remember when they were saying that they had up to just having a few interlock qubits, and the amount of computation that it would do was just, wow, great. One of the things we have to look at is that when AI gets a hold of this computing power, it's just going to be able to do even more than the 10% 10x that it's growing every 6 months. By the way, 10x means in a year it's 100x, 10x times 10x. And that's what we're seeing now in the growth of AI. The chips that they're using for that are growing outstanding, and the processes they're using are getting better, and they're figuring out ways to use less power, less space, and put it in different places. The new iPhones have an AI chip embedded and are doing computation. And there's a lot of that stuff going on, and a lot of talk about whether or not it's going to do any good. Yes, sooner or later it's going to be that every place you can put a chip, which is everything in modern life, you're going to be able to put an AI chip and have it do more things. And just phenomenal opportunity there. But let's take a look at where the quantum computing can help. Anything that takes a whole lot of computation, and like trying to see the whole universe full of stars and galaxies and where they are, be able to do cryptography, will break the cryptography that we all use today, and also enable cryptography that I'm not even going to begin to try to explain because I don't know what I'm talking about. But more practical things are logistics. It helps to know when you're, say, running a retail store, how many of each item you have and exactly when somebody decides to buy and do something. And they've taken AI and put this into the computation that can be done by a quantum computing, be able to find out how to set up where the stuff goes in the stores, how to make the deliveries to all the houses, things like that, think Amazon vans and post office trucks delivering things. This came to me just the other day. I have not had a chance to check out how true this is, but I looked to see that I was on the route to get something from Amazon. And it was interesting because the place where they were loading it on a truck is only a few miles from my house. And in the morning, it said it will be there by 10 p.m. And I'm thinking like, okay, I don't get a lot of Amazon deliveries at 8, 9, 10 o'clock at night, but who knows what they were doing, how busy they are. And I started thinking about where they would know and what the route was. It used to be that I ordered stuff at my business and we shipped stuff and used the same guy driving the same brown truck would come by twice a day and deliver stuff and then come back and pick it up. And we, over the years, got talking about his route and where else he went and whether or not, what time of day. It tended to be just about the same time every day. There may be more deliveries someplace or less, but on average, it came out in a fairly short window of time. And then as we became more of a big shipper, they said, okay, great. We can now instead of being sometime between 2 and 5 in the afternoon, we can get to you at after 4 and we'll be going to make you one of the last ones so that everything's ready and you don't have to wait till the next day to ship it. Great. That was a wonderful way to take care of my customers. I don't know how they managed to do it, but it just seemed like a lot of logistics. And it came to me that, and again, please, if you know about this, leave a comment, let me know. But I'm going to be doing some checking on it. The logistics now are so fast that when I see an Amazon truck or one of the other couriers come by my house, I don't know exactly what time it is. It changes. And I'm pretty sure it's not always the same person. I know I order groceries delivered. It's a different person every time. I know when I get into an Uber and take a ride, it's a different person every time. That routing is done in real time and updated and still uses all the things that made my old daily UPS pickup something I could count on. That there's so much this computing power that needs to be done. And as we move into quantum computers, I see it just happening instantly, knowing where everything is, where it's going to be. Nice to know that today I can look on my phone and it'll tell me approximately what time I'm getting that package. Still, sometimes the one I was waiting for said sometime before 10 p.m. It arrived about 4 in the afternoon, but which is more typically when we get our Amazon packages. But the computation times in one being worked on one grocery chain right now said they were able to go from the computation time of 25 hours to just 2 minutes because they were able to optimize things that much faster. In drug delivery and development, we've already talked about that in another episode about how AI is just allowing so many more computations and virtual experiences in a digital twin to be able to see what a drug combination or compound might do to particular molecules in trying to find new treatments. But think about how much faster that goes when the computational power goes up a million times what we have today. And it sounds weird to say it's going to be a million X, but we are now carrying around phones that have a million times the computation power that early phones or even early computers had. They just keep getting cramming more and more into there. And that means that if there's something you need to find a drug to cure, or you don't know if it's going to cure it, you can say, this is the disease, this is the parameter here. We've isolated the molecule that does it. And in a couple of minutes, come back with an answer. And we need to change our world of how to accept those, how to test them, what else goes on. But the actual coming up with the idea is not about years of research, it's minutes of research. Financial modeling, next thing I wanted to talk about. Yeah, if you're trying to figure out what people want to do when they're investing is get some kind of a certainty and then get a maximum return with some risk. A lot of that risk gets cut out when you just know what's going on in the world. Weather reporting, same thing. That we're now able to, I don't know if you've noticed it, but I've been around a few years. The weather reports get better and better. I still watch one daily that shows how many degrees above excessive hot it's going to be here in the desert of Las Vegas. But it's interesting that the announcer will say a number. It'll come up with what the temperatures are for the rest of the day, and that'll show a different high. And then they'll show out the 10-day forecast, and the first day being today, we'll have yet another number. So it'll be three different numbers because those are compiled so close to when they are broadcasting them, they don't get all their graphics lined up. How exactly they make that mistake, I don't know. But having worked in broadcasting and dealt with incoming inputs that go into those kind of things, seems very likely that it's a matter of they can't get all of them all coordinated all at the same time. It just reminds me every day that even though whether or not it's going to be 1 degree off or 2 degrees down is not going to change my life much, it reminds me that we're still trying to work out those forecasts. Right now, a 10-day forecast pretty well tells you if a storm's going to be coming, whether or not you're going to have rain this weekend. And of course, here in the desert, it's pretty much going to be sunny and hot most of the years. But I remember when I was in broadcasting, seeing demonstration of newfangled systems that were going to allow you to track storm. And we thought, wow, we weren't a news station. Why would we ever need anything like that? Today, anybody can pull it up on their phone and see the storm moving. And if you zoom in enough, you can actually see whether the storm is a mile away, headed the other direction, or it's right on top of you and there's a lot more to come. Not that I need to know the weather down to that degree, just like that temperature example. Don't need to know that, but it's interesting to know how much better they're getting. There are places where knowing the weather's that important, and to know whether to plan major outdoor activities like stadiums and traffic control. And of course, when you get to snow, whether or not you're going to be able to get to someplace, whether the hurricane's going to hit here or 10 miles down the coast, are things that they watch very closely. And of course, will just get better and better. They haven't figured out any way to say that they have a goal of modeling, so we'll be able to tell you what the weather's going to be like a month from now. But wouldn't that be interesting to know that even though it seems like we're in a drought, we're going to have major storm coming in 3 months, and when it comes, we're going to wondering why we were praying for rain so much. But, but we'll know more, a more accurate. And I think what I've experienced, again, the caveat is that I live in a desert, that when it's going to snow and how much rain is going to come and some things like that, or where's the hurricane? We did have a hurricane hit Las Vegas last year. And when it did, there was a light drizzle. Because the hurricane had come far enough inland that it didn't bother anything. But I could watch that because they were saying it's coming inland, it's going to get to us. And I watched it as it tore through Mexico and did some damage in Southern California. And then by the time it got up to us, there wasn't anything left. And they pretty well knew that, but they were taking precaution because society's built on trying to plan for things that we're uncertain about. When in fact, we're getting more and more certain about what those things are happening. These are just some easy examples. In anything that you're trying to model, it's there. If you're trying to do a pro forma on how much you intend to get in revenue and how much you want to spend for budgeting, you're going to be able to know a lot more. And the computers are going to be able to remember that, hey, there is this list of 100 things that have happened to you in your life, medical emergencies, car wrecks, whatever, like predicting things like that, and give you an answer. In insurance, there's people that do this full time in the assessment, figuring out actuary tables, how many people are going to die at a certain age, at a certain time, in a certain gender, race, where they live, what their occupation is. Those are people put a lot of time and effort into that. Well, we're all going to have that kind of information. Knowing when we're going to die might be a little bit more than we want to know, but it is possible now. I just watched a program about an hour ago that was talking about this, that about longevity. And hey, I don't know what's going to kill me, but I do have a good idea that whether or not I'm healthy, because I can take a blood test and it's going to tell me what my biological age is, not in the number of days I've lived on the planet, but based on systems that are going on, the molecules inside my cells, whether or not it predicts me to go for the normal age, early, late. And they were actually coming out with a number. Guy says, I'm 63 years old, but my biological age is 45. And he looked fantastic. And he'd been a guy that spends a lot of money and time on it, and he's done well. The other guy he was talking to does the same, didn't look as good, looked a little gaunt, but had 6% body fat and says he feels like he's in the best shape ever at somewhere around 60. Fascinating what we're going to be able to do, what we're going to be able to plan. And with all the other technology that's coming along, it's going to be just as certain as you need it to be, with still a little bit of uncertainty, because at any time the asteroid could hit us or something else could change. But we're going to have a lot less of this fear of having to live with chronic disease for a long time and stay healthier for a long time. And I think it all is coming together as the emerging technologies come together and times exponentially. I think in exponential, you just increase the number. You don't say exponential times exponential, but something like that. These factors are just all growing and looking so good to us. So that's my take on quantum computing. Expect to maybe not see it in something like a quantum computer in your cell phone, but quantum computing doing a lot of work in big iron type research, and where the whatever it's taken to train AIs and things like that, it's going to become on mainstream and probably end up making us safer and happier in everything that we do. But we'll leave the privacy for another episode. And that's it for today. I'm Warren Whitlock for Emerging Technologies, and stay in touch. Let's keep learning together.